Hello class, in this tutorial I am going to show you what you need to do for problem 9.74. You need that moisture Excel data file. It looks like this. It's got two columns for our Boston shingles and our Vermont shingles. So one thing you need to know for this problem is you're going to need to know that the mean and standard deviation are going to be needed for this, because we're going to be doing a t-test again. However, so you can go ahead and calculate those if you want, simply using syntax for the average and standard deviation, or you can use the data analysis tool pack, or what's even nicer, you don't even need to do anything. We're going to let PHStat do it all in one shot. So with that, we are going to go to PHStat, one sample. Tests, we want the t-test for the mean sigma unknown, very similar to problem 9.44. Our null hypothesis here for A was that it would be less than 0.35 pounds. So we just put in 0.35 there. Again, our significance is 0.05. Our sample size, our sample mean, our standard deviation. Now, this is what I was talking about. You need to know that you need it. So you can go ahead and put it in there if you want, or we can check this little radio button here where it says sample statistics unknown. Basically, that's saying, hey PHStat, you need to figure this out for me. I'm feeling a bit tired and lazy today. So we're just going to grab our data, so click into the sample cell range and select the column for Boston. Check the box for first cell contains the label. Okay, and now remember we need to specify our tail here, and it's going to be a lower tail because they're thinking less. So we will do a title of A and click OK. Lo and behold, we get this output telling us don't reject the null hypothesis. And why is it telling us that? Because if you remember, our p-value here is one of our most important elements. It is greater than 0.05. Okay, so that's a bad thing. So it's very easy to say here. It says, look, 0.07 is bigger than 0.05, so reject that. In fact, the syntax here, you can even click on it and it's telling you, hey, if B17 is greater than cell B05, reject it. So that's how that works. Now, the one thing I failed to mention about significance testing or hypothesis testing here is I'm telling you always look at the p-value, because that's what happens in reality. Technically, you're also supposed to compare the critical value against the calculated value. So this and this. And if one's bigger than the other or less than one of the other, it's supposed to aid in your decision making. But the reality is you're never going to get, they're always going to be congruent. Your p-value is either going to be less than or greater than 0.05 in the same direction of whether or not your critical value is greater than or less than your calculated value. So it's rare that you'll ever see anyone report a statement that says, oh, our calculated value is greater than our critical value, therefore blah blah blah. You just don't see that. You'll see that they'll say their statement, our findings are significant or non-significant based on a p-value of x in relation to it being to 0.05. So I just wanted to clarify that as well. So that was A. You can just repeat the process for C and you'll get an opposite result here. And so that's 9.74. Don't forget the rest of the problem, meaning the writing part of it. That's it.